Alright, so we're going to talk about ratios, and this is just a review for the test we're having at the end of the week. Remember, a ratio is two numbers compared to each other. So you could have something in a ratio to each other, for example, of 1 to 3, which means that for every one part of something, you will have 3 parts of something else. Remember, we've learned that there are many ways to express this type of ratio besides this written form here. This same ratio could be expressed as 1 to 3 this way. It could be used as a fraction or expressed as a ratio as a fraction. 1 to 3 is another way of doing it. We can also find an equivalent ratio, which means we will multiply the top number and the bottom number by the same factor. If I just pick 2, this one right here, 1 to 3, would now be 2 6, which you could write as a fraction, or you could write as along those ways. And if this wasn't already in lowest terms, you could have taken a ratio and reduced it to its smallest number. But there are multiple ways to express ratios. But what we're going to look at today is how to tell if ratios are proportional to each other and what to do when we know they are. And when we talk about this, we are going to be doing cross multiplication today. Cross multiplication sounds like cross cancellation, which is something else we're reviewing again right now on how to multiply fractions and make them smaller before you get into it. But please don't get the two confused. Cross multiplication is used with proportional ratios. So I'm going to give you a few examples, and this is the work we had been doing. If I wanted to prove that 3/5 is directly proportional to 9/15. Now, I know some of you can do it in your head and see it, but let's say you couldn't, because a lot of the numbers we're going to use are bigger. So cross multiplication tells you to take a denominator or a numerator and multiply across to the opposite denominator, and do the same on the other side. It doesn't really matter after you multiply which one goes on top, because we're going to show you what you're looking for. Anyhow, if I do it this way, 3 times 15 is 45. And then 5 times 9 is 45. And you will see that if two fractions, or this is written as fractions, but if two ratios, when multiplied using cross multiplication, if they come out to one whole, if they come out to the same number in the numerator and denominator, then they are proportional to each other. So I'll give you another example. If I took 2/5 and made this 25. Now, if we were to tell, if it said this and you want to check to see it's proportional, you would multiply across, cross multiplication. 2 times 25 is 50. And the other way, 5 times 8 is 40. This fraction, or this ratio, because that's what we're really looking at, is not equal to 1. It is not 1 over 1, so this is not a proportional ratio. And if you were to look here, you could actually see it. 2 into 8 is times 4. I had to multiply the 2 times 4 to get 8, but 5 to 25 is times 5. You can see that these two numbers, it's not the same factor that you're multiplying the ratio by, so it will not be proportional. So that's one way that we use cross multiplication. We use it to do a check to see if our ratios are proportional. The second thing we do with cross multiplication is if we have an unknown term. So if we know that they're proportional, if the question has told us that these are proportional ratios, you can find one term that you don't know, and I'm going to show you how to do it. So if we had an example of 2/5 and 8 somethings, we don't know what this is going to be. I'm going to put a question mark there. We know that they're proportional because the question tells us it. We are going to write this as an algebraic equation, and that shouldn't scare you. That should make some of you relieved, because you're getting pretty good at that. In order, I'm going to take this question mark and put a variable. I always like using x. You can do whatever you like. Cross multiplication says you multiply numerator to denominator across the equal sign. It does not matter which you have on the top or bottom. So, but I'm going to go 5 times 8 is 40 and put it on the top, and 2 times x is 2x. Now remember, that looks like a fraction, but really it's a ratio. We are saying that is 40 to 2x. And when we write it, we can write it 40 to 2x. But because we were using these proportional, we can actually write it 40 equals 2x. Once you see it written as this, you know how to solve. This is a one-step algebra equation. We just want to know what x is, so we have to eliminate that 2. We have to isolate the variable. Between the 2 and the x, there's multiplication going on. You know 2 beside a variable or any number beside a variable means multiplication. So in order to get rid of it, we just have to divide by both sides. So in this case, x would be equal to 20. It doesn't matter if the x is on the right-hand side or if x is on the left-hand side. It's still a one-step algebra equation. So in this case, x would be equal to 20. I'm going to do a couple more for you. If our ratio was 10 to 80, and I don't know this one, and we'll put 60 right here. Now, the only thing different with these are the numbers are starting to get slightly bigger. But you're in grade 7 and 8. That should not make a difference to us. We are going to cross multiply because we're doing proportional ratios. The question was set up telling you that they're proportional. First thing I'm going to do is I'm going to change this question mark into an actual letter. I'm going to make it into a T, and then I'm going to multiply across. So T times 80, if I had 1 T and I multiplied it by 80, I would now have 80 T. And on the bottom, 10 times 60 is 600. Now, it looks like a fraction, but remember, we are doing ratios. So they are in proportion to each other. It is 80t to 600. So when you do it that way, we actually write it out like so that we can solve it like an algebraic equation. And all we're going to do is we have to get rid of that 80. We have to solve for just 1t. In order to do that, we do the opposite operation. There's 80 t's there, so we have to divide by 80. And we divide that by 80. And t is going to equal, and that's going to equal 7.5. Now, the only thing you might make a mistake with here, unless you forget that we're really doing an algebraic equation, is how to set this up. So I'm going to go through that with you right now. Okay, so this is kind of a silly question because no one's going to eat 10 pies, but I just needed a ratio to use for you. So let's call these really tiny pies. And the other thing that you have to remember for proportional ratio is that all of the examples in your word problem, they will be constant. They will be at the same rate. So, you know, if you're really thinking logically, you say, well, some guy starts eating 10 pies, he's going to slow down at some point. I get it. But this example was just to show you a proportion. So anyhow, and we had done a lot of questions with pies, so I put it back in. Anyhow, when you go to set this up, you have to write the proportion. So we really are talking about pies to hours. That's what we are comparing. That's what our ratio is comparing. So in the first situation, it is 10 pies to 2 hours. And the next thing, the question part is, how many pies will he eat in 6? That would go here under the hours part. What you don't know is how many pies you would do it. So to set up your work, it kind of looks like this. When you go to write it, that's where you could make a small error. Remember, when you set this stuff up, you have to have your ratios and things that you're comparing all on the same line. So if we were going to compare pies and hours, they would have to be across from each other. So this would be 10, really we're talking about pies, and this bottom would be 2 hours. Now I don't want to leave that in there, I just want you to see it for a second, that the pies are on top and the hours are on the bottom. And when we were doing proportionally, you would have to put the next pie, or the other pie that you're talking about, on the top. This is the one we don't know, I'm going to put an X there. And the hours, which was on the bottom, we have to put on the bottom again. So that both of these, the top ones are all talking about pies, The bottom one is all time with hours. So you put your stuff across the left to right when you're writing them so that it maintains the same ratio. Anyhow, I'll back that out so you don't get confused. Let me move this down. Move one more out. Cool. So remember how we're doing this. We're doing this as cross multiplications. So you're going to multiply that way, and you're going to multiply that way. When we do this, you really get 2x over 60. Remember that we are going to actually write it as 2x equals 60, so that we can use algebra to solve, and we can show our work, and it looks really, stuff we've already done. I want to know what x equals. In order to do that, I have to get rid of the 2. Remember that 2 is being multiplied by x. So to get rid of it, to isolate for x, we have to do the opposite operation. If we do the opposite operation, we have to do both sides. That's very important. So x would be equal to 60 divided by 2, and that's 30. So in the question, let me move that back up. How many pies would he eat in 6 hours? He would eat 30 pies. So basically, that's your proportional ratios. We've had lots and lots of questions. Practice them, and then come and see me if you have any questions.